Hi, we are group number 3 and we are going to be talking about the chemical treatments to preserve the quality of fresh cut fruits. When you are at the supermarket, have you ever wondered how is it possible to keep these fresh cut fruits looking so good for a long period of time? Well, we can find the answer on chemicals. First of all, let's define what is a fresh cut product. Is any fruit or vegetable or combination thereof that has been physically altered from its original form but remains in a fresh state. Okay, so going back to the chemicals, these chemicals are called additives and they can be sanitizers, anti-browning agents, or texturizers. Sanitizers are chemicals that can be used to decrease the number of microorganisms present on the surface of whole and fresh cut fruits to safe levels, something like this. Chlorine, one of the most important and widely used sanitizers in the food industry, has been used for several decades for decontaminating fresh produce. Usually, chlorine compounds have to be used at certain levels of 50 to 200 ppm free chlorine and typical contact times of 1 to 2 minutes and no longer than 5 minutes. When dissolved in water, chlorine converts to an equilibrium mixture of chlorine, hypochlorous acid, and hydrochloric acid. Chlorine-based sanitizers are normally used at pH values that are in the range of 6 and 7.5 to prevent the corrosion of the equipment, but it is more effective at acidic pH levels. In conclusion, chlorine is a very effective sanitizer, but present and future regulatory restrictions force us to develop other functional and safer alternatives. Now, let's talk about hydrogen peroxide. Hydrogen peroxide is an oxidant and has the capacity to generate hydroxyl radicals, which contributes to its bactericidal and inhibitory activity. Solutions of 5% hydrogen peroxide can achieve substantially higher log reduction for inoculated apples than 200 ppm of chlorine. According to several studies, the most effective way of using hydrogen peroxide to treat fresh cut fruits is by dipping them. However, not all fruits react equally to hydrogen peroxide exposure. The appearance of some fruits after treated with hydrogen peroxide can be negatively affected. Another powerful sanitizer is iodine. Iodine solutions are also commonly used as sanitizers in fresh cut fruits because of their broad antimicrobial activity spectrum. One of these iodine solutions is called iodophores. An iodophore is a preparation containing iodine complex with a solubilizing agent such as a surfactant or povidone. The result is a water-soluble material that releases free iodine when in solution. Iodophores are less irritating to the skin and less volatile compared to other types of iodine solutions. Moreover, it is less corrosive than chlorine when used in lower temperatures.
The next sanitizer is ozone. Ozone exerts its antimicrobial activity as direct attack by molecular ozone at low pH and indirectly by the mechanism of free radical formation as a result of decomposition at high pH. Ozone destroys microorganisms by progressive oxidation of vital cellular components. The extra oxygen atom, fused by a weak atomic bond, comes in contact with microorganism, resulting in oxidation. The degradation of cell envelope results in cell disruption and subsequent leakage of cellular contents. Benefits of using ozone treatment include its excellent penetrating capability, oxidation of organic chemicals into safer elements, and rapid decomposition, leaving no traces of oxidation. Also, ozone treatment doesn't interfere with sensory and nutrition quality of fresh cut fruits. Now, let's have a look at acidic compounds. Organic acids such as lactic acid, citric acid, and tartaric acid are used as antimicrobial agents. The action of organic acids are due to a decrease in intercellular pH by dissociation of hydrogen ions from acids, anion accumulation, and interruption of membrane permeability. Ascorbic acid prevents browning in fresh-cut fruits by acting as oxygen scavengers and removing molecular oxygen in reactions of polyphenol oxidase. The action of citric acid is by reducing pH, and enzyme inactivation occurs by chelating copper in active site of polyphenol oxidase. Oxalic acid exhibits anti-browning activity as it has high affinity to form metal complexes with copper ion. Disinfectant activity of peroxyacetic acid in fresh-cut fruits is based on release of active oxygen which oxidizes essential enzyme. Now let's have a look at electrolyzed water. Electrolyzed water can be used for sanitation of washed water in minimally processed fruits by improving safety and extending shelf life. The disinfectant molecules of electrolyzed water can neutralize harmful substances and provide a broad spectrum microbial decontamination. This technique can be used for washing fruits without affecting the nutritional and sensory properties. Electrolyzed water is environmentally friendly and leaves no toxic residues. Quaternary ammonium compounds are cationic surfactants which form a residual antimicrobial film when applied to the surface. The antibacterial activity of these compounds can be explained when cations are attracted to negatively charged bacterial protein.
Now I will talk about anti-browning agents. When fruits are cut, polyphenol oxidase is released. This is an enzyme responsible for the enzymatic browning by oxidizing phenolic compounds in fruit and initiates the browning reactions. Anti-browning agents are chemicals which are used in browning control. They can directly inactivate polyphenol oxidase or influence other factors in the browning process. Anti-browning agents can be classified into these manners: acidulants, reducing agents, chelating agents, and other anti-browning. Acidulants are chemicals that lower the pH of products. Because polyphenol oxidase activity is minimized at pH below 4.5, so reducing the pH can inactivate the enzyme. However, it is difficult to reduce the browning by only controlling the pH, so acidulants are often used in combination with other anti-browning agents. Some popular acidulants are citric, malic, and phosphoric acid. So how about reducing agents? In the first stage of browning process, orthophenols are oxidized to orthoquinones. So reducing agents can react with the quinones to reduce them back to phenols, so they can limit the browning process. However, their effect is limited because reducing agents are oxidized when react with quinones. Some widely used reducing agents are ascorbic acid or cysteine. Another type of anti-browning agents is chelating agents. They are compounds that have ligand binding atoms capable of binding copper in polyphenol oxidase active site to form complex ring-like structures. Some chelating agents used in fruits are citric acid, EDTA, phosphate compounds, or kojic acids. Furthermore, there are some other anti-browning agents which are applied on fresh-cut fruits, such as the 4-hexane resorcinol in combination with ascorbic acid or chloride salts of calcium and sodium, which are used as enzyme inhibitor. Moreover, enzymatic treatment using protease are also applied to inhibit the polyphenol oxidase. In addition, benzoic acid and cinnamic acid also have some limited effects.
Besides sanitizers and anti-browning agents, chemical texturizers are also used in maintaining the firmness of fresh-cut fruits. So why do we need texturizers? Because during physical processing and cuttings, enzymes are released from cells and degrades the cell wall components, which results in softening of fruits. Soft texture is considered unattractive for consumers. The two enzymes involved in cell wall degradation are pectin methylesterase or PME and polygalacturonase PGs. PME demethylate pectins to produce methanol and lower methylated pectin molecules. This allows the depolymerization by PGs, leading to cell wall degradation. Calcium ions could interact with the free carboxyl groups liberated from the deesterification of pectins by PME to form insoluble calcium pectase. Calcium salts include calcium chloride, calcium lactase, calcium propionate, or calcium ascorbate. Calcium chloride is the most common calcium salt used as texturizers. The firmness of fresh cut fruits is proportional with the concentration of calcium chloride. However, its bitterness or the appearance of calcium residues on the surface of fresh cut fruit. Calcium lactate is considered as the alternative calcium source for firmness maintenance of fresh fruit because it produces no bitterness, but the firmness is maintained longer than using calcium chloride. Also, calcium lactase minimizes the browning reaction and acts as a pH stabilizer. Other kinds of calcium salts are calcium propionate and calcium ascorbate are used to preserve the firmness of Fuji apple and fresh-cut Gala apples. Calcium salts could be combined with eatable coating in order to improve the firmness and minimize water loss of fresh-cut fruits. For instance, calcium chloride could be combined with arginine gelates or pectin polymers or with anti-browning agent in whey protein concentrated coating.